Louisa back. That's right. You got a Jar Jar. You deserve Jar Jar. So today I'm meeting with Brian from Qdrant. We're talking. It's going to get mathy. There's going to be math. Going to have to deal with it. We're going to figure out once and for all if Phantom Menace is the best movie, which it is of the Star Wars movies. It just is. You have to accept that in your heart. Okay. Once you've accepted that, everything gets better for you. No, beyond that, it's a really cool, Qdrant's really cool vector-based search. I'm going to go way into explaining what that means. So I'm not going to gild the lily here. I'm going to say, always join the Discord. I have a very special link in the show notes. I actually was interviewed by USA Today, so I got a link to that. Good stuff. Also, this is the first time I'm mentioning it. Go to vorpal.bot. That's VORPAL.bot. To check out my new IoT-focused ERP system for MROs and weirdly industrial agriculture. It's, I think you're going to find it pretty cool if you're in either of those spaces. It does, of course, tie into Alice. We can bring your legacy data over. Just launched as I'm recording this. It's February 11th. And yeah, so it will be out before you know it. So literally probably the same day as this. Good stuff. There's a discount if you're interested in giving it a kick in the tires. There's a 15% discount. Just use the show Jar Jar, the code Jar Jar, or code or whatever. Just say you heard it on the show. And we'll go from there. Always check out the Discord. We do have the mailbag episode coming. We also have another interview coming that had some audio production issues and is going to be a little out of time. So the timeliness wise, this actually is coming out right when I recorded it, just about. So. Good stuff. Also, we are going to have out that portable game system episode very soon. I just finished my review of the PlayStation Portable that I have to write up, and the ROG Ally, the weird Microsoft edition, and of course the Steam Deck and Steam Deck OLED. And I included the Switch, but I think it's kind of an affair. So yeah, that should be up. We're also going to be doing something with Linux gaming pretty soon, I hope. Once the Steam Deck is out. So kind of a couple light things coming up, but then we're right back to the enterprise. So don't worry, big data nerds and people who love VPNs. We're gonna be right there with you. So like I said, check out the USA Today link, check out Vorpal, join the Discord. Here's Brian. Okay, prepare your Bon Jovi, your Bruce Springsteen, and fist bumps. Brian O'Grady is coming at us right from my home, the Great Garden State. In fact, from my county, Middlesex County. Brian, how are you?
I'm doing well, Michael. Thank you.
It's great to talk to a fellow Piscatawayan. Is that how we call ourselves?
Not exactly sure. Piscatawayan, Piscatawayite, undetermined.
Oh man, it's how cold is it up there these days? I'm chilling here with my pina colada in Tampa.
Yeah, we're sitting at 32 Celsius. Sorry, I have my in-laws in the house. They're from Brazil. I have to translate to
Metric.
Celsius all the time,
Yep.
But it's 32 Fahrenheit. It's actually somewhat warm. I can tolerate going out in, just like a t-shirt now, because over the past few weeks it's been hovering around 0. So much better than recently.
That is terrible. I'm actually flying up next week. I do not look forward to it because I've become very cold-blooded down here, very reptilian.
It's going to be a shock to your system.
I'll be very alert. I will be coding faster than ever, I think.
There you go.
So that's not what we're here to talk about, my strange Florida man habits. Qdrant. So what the hell is Qdrant?
Yeah, so I guess I'll start out with kind of what we call ourselves, right? Qdrant is a search engine, and if many people in this audience have probably dealt with or heard of technology like Elasticsearch or OpenSearch. We categorize ourselves as a search engine that is specialized for vector search. So when you think, Elasticsearch, OpenSearch, anything that's based on sort of, the tried and true Lucene, you think, oh, this is like a text search engine. So I go on to retail website. Let's say I go on like homedepot.com. You start typing in, I want a ladder, right? So you type in ladder. When you're typing there, you get the drop down and it starts doing this like search as you type. And then you can click on, ladder as it auto populates for you. It takes you to a page and then it'll show you a bunch of ladders. This has been the market. These kind of retail giants have traditionally served their search via Elasticsearch, via Solr, via
Solar,
OpenSearch,
yep.
what have you. But where Quadrant comes is we are not focused on the text layer of the search. We are instead focused on something that we call like the semantic layer of the search. And this is where maybe things get like a bit deep. This is where things get like relatively nascent, but there was this development in 2019, 2020 in the machine learning space where researchers were able to transform text into numerical representation that preserved meaning. I'm going to stop there to see if, Mike, if you have any questions on that.
Yeah, so it's interesting, right? So I think, and I could be wrong, that the folks listening are going to be most familiar with are going to be Elasticsearch, right? The Amazon solution. And just because I'm incredibly self-centered, I'm familiar with Solar.
Okay.
So I wonder where do you differ from, say, an Elasticsearch? I think that might be the more popular one.
Yeah. So, and this is where it starts getting into what the search engine was built for. And this is where I'm going with my whole, text having a numerical representation
Sure.
story. So the idea is that if you're just doing, say, keyword search, then that leaves out a lot of context, right? Like if I search for a bat on, a generic website, let's say I search for like bat on, Walmart.com, it might return, stuff to do with like Halloween because it's thinking bats like the animal. It might return baseball
Batman.
bats. It might
Yep.
return something else, right? It's kind of unclear. Now, a word standalone bat, that doesn't tell you much information, but how people are normally interacting with search bars these days is they're kind of inputting these more like free form queries that somehow give context to like what the person means when they say bat. But the issue with keyword search is that it is not able to understand like the actual context. It's just sort of doing like a sort of exact match for keywords, right? And then returning results based on sort of statistics and not really trying to understand, quote unquote, the meaning of the search. So the real advancement that happened in the late 10s and earlier in this decade was this ability to take text and encode its meaning structurally into something called an embedding, which is also known as like a vector. So this is where vector search comes in. So rather than saying, hey, just look for results that contain, like I type into, another good example might be, let's say I'm using like DoorDash and I want to type in the search, like tasty fast food burgers within 5 miles, right? Like that might be
Right.
something I might say to DoorDash. Rather than trying to go ahead and look at all these words that are in there and try to match them to results, like if I look for tasty, right, and then try to match it to a result, that's kind of odd. Like what kind of results actually have food descriptions have tasty in them? Maybe a
Tasty in
lot,
them.
right?
Well, maybe, yeah.
Maybe. But like 5 miles away sort of becomes the issue where it's like, oh, okay, that means near me, but 5 miles away now starts getting brought into my text search, right? And I'm now
Mm,
looking for results that have the sequence of words 5 miles away in them, which is like going to be none if you're thinking about like a description of a food item. So what embeddings are able to do is they're able to sort of strip away the irrelevant context of text and only focus on like what truly matters and like what the meaning of what someone's saying is. So when I say, hey, I want like, tasty burger 5 miles away from me, what I'm really saying is I want like a possibly sandwich like item that is near me, right? And I just need to show results that are near me that have like a burger or sandwich like item, right?
right, right. So
Um,
the operative part is the range, right? The distance is more important than
yes.
almost anything of that. Yeah.
Yeah, yeah, but like the distance becomes a slightly different thing here. But what really matters is that now we're able to say, hey, like I'm able to understand that burger is related to like McDonald's, burger is related to
Mm.
Burger King, right? Burger is related to what's another Five Guys, right? But maybe burger isn't associated with like Popeyes. So now when I'm doing my ranking, there's this kind of latent association between disjoint words, right? Like burger is associated with McDonald's that you would not be able to capture in traditional text search. But like with what's called semantic search, where you're representing data as when you're representing text as vectors, you're able to essentially do like, if you remember from your sort of on like pre-calc days when you take
Right.
like, you drew on like a quadrant, no pun intended. You drew a quadrant, right? You have like 2 points and then you calculate like the literal distance between them. And then you take like, you can do this in hyperspace. You can have a vector that is a representation of text that you can then say, let's find the literal distance between this representation of text as a vector and this other piece of text that is also represented as a vector, and calculate the literal distance between them to show what is most relevant to the user's query. So that's kind of like the very technical way of explaining it. But the way I kind of try to think about it is people get really hung up on this idea of like, well, what is this guy talking about? He's talking about text as vectors. But like, we actually need to take a step back here and say, what is text itself? Right? Like, when we say text, we kind of take text for granted. We take words for granted. We take language for granted. And what it really comes down to is, if you think about it at a very granular level, text is simply a representation of language and meaning that we use to communicate with each other and to embody knowledge, right? That's why
Right.
like there's a lot of, I don't know if you ever read any of those books where it's like a book about a book that is powerful, right? And when people read it, it like transforms their lives
Yep.
and
Yep.
everything, right? Like there's tons of books out there that have this, where books are sort of like this independent entity that are able to influence things around them. It's
Damn
this
you, Atkins.
idea.
Damn you. Sorry.
Sorry, go ahead.
No, I said, damn you, Atkins. That he killed everybody with that book. Keep going.
Yeah. So the idea is text is simply a representation of shared language and meaning that humans are able to communicate to each other. So text is a simple representation of this meaning that we are somehow communicating to each other with language. If we think about how could a computer somehow like learn that same meaning and be able to communicate it, what you can do is you can simply say, well, let's simply, instead of representing language and meaning as text, let's represent it in bits and bytes, aka
Mhm.
numbers, like floating points and associations of floating points. So like vectors. So really an embedding and vector search comes down to this ability to take language and meaning, and rather than encode language and meaning in like words and text, you simply encode it as numbers. And it's just another form of representation of meaning. And it's one that you can now perform mathematical operations on that are very convenient.
Right. So let me kind of dumb this down, because I think you got a lot there, right? So vector is oh God, I'm gonna just you're gonna want to choke me for this, but super simple for perhaps some of our folks in the audience who might still be students or something like that.
Yeah.
A vector is a mathematical. I don't like the word construct, but let's call it that. All right. It has both the value and a direction. And that's the key, the direction stuff. So
Yeah.
in Brian's example of the hamburger, right, that was, the hamburger, what was it? I want a burger 0.5 miles away or something.
Yeah.
Burger is both a value and a direction, where pizza would be a value, but a different direction. I know it can get trippy. This is, when you take calculus, you're all going to cry. So the idea is, what stupid search, let's say you're using like an ORM right now. And this is, I know senior data guys are going to want to send me mean emails. Go ahead. It's fine. Let's say you're using like Active Record. I'll give you the easy example. You can use the built-in search functionality, but it's literally going to do a string comparison in Postgres or whatever your underlying database is for, a burger would be BURGER. And that's all it's going to do. It doesn't understand, like, burger means bread, meat, maybe some lettuce, right? And onions. What a vectorizing it, and what Qdrant's doing, what Brian's trying to explain, I think very well actually, is you assign a mathematical value to the concept of hamburger, and that value would also be nearer to the concept of, let's say, I don't know, steak sandwich, French dip, something like that, right? Then it, in terms of quantifiable value, be closer to those than it would be to, let's say, sushi or, martini. Is that fair, Brian? I know I'm like
Yeah.
way boiling it down, but
Yeah. And like we can even go further to say that, if you think about this idea of just, what things are close to each other, right? We can go kind of further. A good example, actually, that we may have missed on, unrelated to burger, but if you're just doing like, let's just say you're just doing full text search, and let's say like very close synonyms. Let's say the word dry versus the word arid.
Mm,
They mean like the exact same thing
yes.
practically, right? Like they're just slight variations on the same underlying meaning, right? But if I'm do a search, in Google and I'm like looking for, arid, something arid, right? And it looks for, I say arid climates, but all of my search results, I have no search results that contain the word arid. They all contain the word dry.
Why?
I'm
Yep.
going to get no hits because suddenly I have filtered unnecessarily. I've done like a keyword match for a word where none of the documents like contain that, right? So the idea is that by encoding pieces of text as numerical values, as humans, we know, like, and English speakers, we know, like, dry and arid mean effectively the same thing. But, like, you know, a text search engine does not necessarily know
Does not
that.
get it right.
But by transforming them into vectors, we're now able to say, just like we're able to kind of like mentally map them to the same space in our brains, we're able to say, hey, like, yeah, dry, arid, they're kind of like the same thing, right? Vectors are now ways to simply represent that close association mathematically
It's
via
perfect.
like a literal distance function.
That's perfect, and, like, just like a visual example for folks, right? And by the way, great name for your company, Quadrant. You've got it perfectly. Because what I'm gonna say is think of a giant quadrant, and every value, hamburger is one thing, arid is one thing. They're all gonna be, in a theoretical location relative to each other, where arid and dry are gonna be very close to each other in that, let's say, 3D quadrant, right? Where hamburger and steak sandwich are gonna be maybe on the other side, but also close to each other, right? It's the relative conceptual, quote, unquote, "nearness" that we're getting at here. Crazy, not crazy.
Yeah, no, it
Yep.
and it could get like way more interesting just to take some examples like further. I just had one when you were speaking. Like I was like, oh, what would be like really different from a burger? And I was like, oh, a brick, right? A brick is very different from a burger. Like when I
That
when
that
I
is
think about
different.
them when I think of burgers, I don't think of bricks, right? It's like the opposite of bricks. So like if I think about them in sort of like some quadrant, they should be very far away from each other. Like they should be nowhere near each other. But then I'm like, oh, well, what about like the sequence of words brick and mortar? Brick and mortar could mean like, a little local restaurant or something. The sequence of words brick and mortar may be able to be like closer in my mind to burger than I would have thought because I'm like, oh, brick and mortar could mean like a brick and mortar store, a brick and mortar restaurant, right? Like there's these slight nuances where depending on the context, the combination of words, suddenly the meaning could become a bit closer.
Right,
Does that one make
and
sense?
no, it makes ton of sense, and there's a subjective element too, right? So this is where I'm sure as a developer, you can kind of play around a little bit. For instance, I would put The Phantom Menace right next to Good Movie and Jar Jar Binks right next to Hero. Now, my email tells me that, I'm alone in this assertion, but, that's where, your creativity comes in, right? You can, uh so let me try to roll this back to, like, practical uses for a quadrant, right? I'm assuming that if I implement this, let's say, I don't know, I'm a store, right? I can then kind of massage how the search relates things. Is that fair?
Yes.
Yeah.
Yeah. And it
So
also enables you to search in ways that you were unable to previously. An example being coming back to this idea of embeddings representing sort of, meaning into a generic quadrant or space. There have been developments where you can actually take text and you can map it to images. So you can do things like text to image search. So you can say, hey, show me, red Nike shoes, right? And rather than like looking at, a product description that says red Nike shoes, it'll look at like images that are encoded in the same vector space. And it's able to say, oh, this image has red Nike shoes in it or something close to it, right? It might just be like a red shoes, red sneakers, but it'll show them to you as a search result.
right, and this is key because you're not just doing a search query on strings. You're actually able to search images and other kinds of media, which,
Yeah.
Yeah, I mean,
And this is where it's like, it's search over meaning, right? And that's kind of where I was
right.
trying to get with my philosophical intro, which is like, it's this sort of it's this sort of odd, space of meaning where humans are able to kind of map things together. We're trying to represent that mathematically, essentially. That's what researchers are trying to do.
Makes a ton of sense. So let's jump ahead a little bit. Let's say I'm a developer. I'm interested in implementing this. What what dependencies do I have? What do I need to do? Let's say I have an existing enterprise. I don't know. Let's stick with our retail example, right? Let's say I'm a whatever a chain store, and I want to implement Quadrant.
Yeah. So in general, right? Like what'll often happen is that companies will have some sort of existing search solution. They'll be on, Elastic or OpenSearch or Solar, right? And the idea is that those engines were built for text search specifically. So for text search, they're very good, right? Like they are able to do, things like tokenizing very well, and you're able to do things like multilingual tokenizing and stemming. It works very well. But the idea is that when you try to introduce this concept of vectors, you're no longer utilizing the same, even like data structures to do your search. You're now doing these very computationally heavy mathematical operations that are like CPU intensive, right? And they put a lot of stress on your existing search system, because now, rather than just sort of doing like a lookup in like an inverted index to see, oh, which search results contain this keyword, you're now saying, oh, let me do distance comparisons, right? Which are very computationally intensive, because you need to, let's say you have a vector that has 1024 dimensions. That means that in a single vector, there are 1024 floating point numbers. To compare two of those vectors, that's 1024 comparisons, right? And that requires CPU. So what I often see happening is that these customers will try to leverage their existing search solution, so Elastic or OpenSearch, to do these vector comparisons. So they'll generate the vectors for all of the pieces of text that they have in their sort of catalog. They'll store those vectors next to the catalog item descriptions, and then they'll try to do a vector search. Now, vector search, as I said, is computationally intensive. And if you said to yourself, oh, like, how do I do vector search over 1 million catalog items? Your first attempt might be, well, let's say I have a, text input. I convert that into a vector, and I just compare it against all of my catalog items. Well, now we're talking about doing 1 million comparisons, right? That will take forever, doing 1 million mathematical distance comparisons. So what was introduced in like 2014 or 2016, something in that time range, was this concept of approximate nearest neighbors, where rather than having to do, 1 million distance comparisons just to find what the mathematically nearest vector is to, your input, you approximate it by leveraging sort of clustering inherent in your vector space. So the idea is that, just as we were discussing, like we think about arid and dry maybe forming like a cluster, we could also think about like burger and sandwich forming a cluster, and then like brick and stone would form a separate cluster. And then there might be like a bunch of clusters everywhere, and they're kind of like interconnected. There's this idea of trying to take advantage of this inherent pattern in the vector space to get results that are closest to your input query in meaning, without having to do a very computationally intensive search of like, doing every single
Right,
comparison
right.
against every
Power
item you have.
right, trying to
So
power through a whole database.
yeah, this concept of approximate nearest neighbors is still relatively computationally intensive, because it still involves doing some distance comparisons. So the idea is that when people try to bolt this on to Elasticsearch or OpenSearch, it often degrades performance of their existing text search system. So what they do is they then say, okay, well, I'm going to now, maybe I have like a cluster on Elastic or OpenSearch for my text search. I'm going to stand up another cluster on Elastic or OpenSearch for my vector search. But then the question becomes, if I'm just using OpenSearch or Elastic, I already have a dedicated cluster for vector search. Should I really be using that tool, or should I be using a tool that was purpose built for doing these exact type of operations? And that's where Qdrant comes in. So Qdrant and like Qdrant's written in a systems language that has no garbage collection overhead. So it's written in Rust. And I know that some people out here are like, Rust is kind of overhyped. But for
Click, click,
database,
click your claws, crab people. Here you go again.
yeah, no. So for database engineering, there was a design choice, right? So
Yeah.
needed a systems level programming language that had memory safety, right? For building a database. This was the core requirement that our founders had when they started Qdrant. They were trying to solve this exact problem of how do I do, vector search at scale for e-commerce, right? Theirs was actually like a job matching website. And they were getting choked on Elasticsearch because of the memory overhead of the JVM. It just was kind of inhibiting them from taking full advantage of their resources. They needed to kind of go in, they needed to tune the JVM heap, and they just felt that the functionality of Elastic, I mean, this was back in the day. Elastic has added much more functionality since then. This is back in like 2020 or 2021. They were like, well, why don't we just build a system that is specifically designed to this exact one thing? So that's how Qdrant came about, and it fits in the stack as this dedicated engine that you use for vector search. But where it becomes a bit more interesting is that you don't need to just use Qdrant to. Let's say you think, okay, well, it's just for doing like e-commerce search. It's actually not. Qdrant is very flexible in how it can be deployed.
Right.
So I can deploy Qdrant in like a cluster mode on like EC2 instances in my cloud. I can deploy Qdrant via Docker locally. I can actually deploy, and this is where I was taking a look at, Mike, your repositories. I can deploy Qdrant on the edge to do vector search on the edge. And we actually just released a demo that shows Qdrant operating on a pair of smart glasses to do image detection in like real
Nice.
time. So it's like
Nice.
really cool.
Yeah.
And the key thing about Qdrant here is that it's not like just an embedded library, but it has the functionality to take the embeddings that you have locally on device, operate offline, and then when you come back online, like let's say you're like a remote worker and you need access to like a database of like information, you can access the database of this information locally using Qdrant. And then if you're like doing a chatbot and you're like talking to a chatbot, for instance, and you want to then send your conversation history back to some like remote database and do syncing, Qdrant can do this. So it can sync a remote cluster with a local embedded device and manage the synchronization and like the indexing of all the data. So it's kind of this idea of build once, deploy anywhere. You can take Qdrant, you can put it on a pair of smart glasses, you can put it on your iPhone, you can put it on EC2 instance on your Mac. You can even put it on a supercomputer. There's been some research showing that Qdrant can like run pretty efficiently on like some supercomputers at the Argonne National Lab. So yeah, that's
No,
Qdrant.
that's all perfect. So just wrapping up a little bit. Let's say somebody's interested. What is the best way for them to reach out to you? I mean, obviously you have the get started page. Obviously, you guys are open source and you have commercial offerings. Is it simply to kick the tires on the open source, go to that developers page and get started, or is it? Do you recommend they reach out to your team first? What do you feel is kind of the let's call it the Goldilocks path, right?
Yeah, so where I see a lot of people having success is that they start working with Qdrant on open source. I
Okay.
think that from a developer experience perspective, it's very easy to work with. People like it because if people are accustomed to, standing up their stack in Docker or whatever, Qdrant's just like another few. It's like a very simple Docker YAML. Like it's very, very, very,
Right.
very simple.
Containerized. And I will say, Brian, his open source model is just much nicer than mine, frankly. We were discussing off the air. Very, very generous open source model. So.
Yeah. But I would say that otherwise, like what people often do is we have a community Discord where people, if they're
Perfect.
having questions, they want to get started. But like that being said, if people have like further questions, they can obviously, reach out to us via our like contact us form. Or, I mean, even like if people feel like reaching out, like You can find me on LinkedIn and ask me questions about embeddings or whatnot. I tend to answer people on there. Yeah.
Perfect. All right. So last question I always wrap up with, and it's a little bit of a curveball. What is one tool, using the word tool like super loosely? I had one guy come on here and tell me it was a Steam Deck, totally fine. That you can't live without. The only stipulation is it cannot be something you make. So it can't be Qdrant, right? It can't be any of your, other side projects. I got him. See, I got him. Stumped him.
Yeah. So it can't be. So you're saying it can't be anything I make.
Can't be anything you yourself make, right?
Okay. But it has to be some tool like I use for like development or something.
Nope. It can be anything. We've had Steam Decks. We've had a shocking amount of coffee related things. It could be anything. Yeah. So it's at least like 40, at least no 50%, I'd say, are like, well, I have an AeroPress. I'm like, I get it. Everybody likes coffee. It can be a coffee thing though.
That's funny because I was going to default to like a coffee thing, but I was feeling like it might be too cliche.
No, what's your coffee thing?
No, I do like it, but I was trying to think if there's maybe something else because there's definitely other things like that are out there.
We had
Because
one
I got
guy.
a couple kids, and I'm like, oh, there's something with them that like I definitely couldn't live without, like in terms of a tool I have for
Oh
them,
yeah.
But I'm like, like what is it, Yeah, I'm gonna have to go with just because the first thing that came to my head was coffee, so I'll have to go with. I got a DeLonghi. I got one that makes like grinds the bean for you,
Nice.
like fresh. So I'm like very addicted to it now. I've become very much a you should grind your coffee type person, but like I'm not religious about it. It's just I waited a year and a half. My wife and I one day were like, let's get each other like our first anniversary gift. We'll get ourselves a DeLonghi machine, and we looked at the price. We were like, wait a bit, and then like a year and a half later, it finally came on sale, and we bought it.
Yep. That's how my wife and I got our Breville espresso machine. So
Yeah,
it was like, it's our anniversary, and frankly, we don't need anything, right? But we do love coffee.
yeah.
So no, that's a perfect choice. I've actually joined your snobby club of every morning I grind the espresso and I make myself an Americano. Yep.
Yep.
So, I used to do the AeroPress, but I have enough burns now because I'm just incompetent apparently. I can't manage that mechanism. Uh, I I really wanted to because one of the best cups of coffees I've ever had was made on an AeroPress, but I simply can't do it without burning myself. So that's just where I am.
And if we go the opposite way of something I could live without, since you're a fellow Jersey native, it would
Yes.
be delays on New Jersey Transit. That I could always
Yeah. Oh God.
I could always do without
Especially in
those.
the winter, right?
Yes,
When it freezes
terrible.
up. Yeah. I used to commute to New York to the meatpacking district, which is not as scary as it sounds because at least back then it was just a bunch of hipsters and tech people. But I'd have to get up. At the time I lived in Eatontown, so I had to go to Little Silver Station all the way to Penn, and then get the subway. It was brutal.
Man, my parents live down near there. It's like this small world.
Oh, you're
Dad live
kidding.
down near Eatontown. It's funny.
Oh yeah. It spent a lot of time at Fort Monmouth, so it was.
They're bringing Netflix bought that. You know that, right?
I know. I used to have an office in Fort Monmouth. I'm very annoyed. As long as Netflix does a good shot. Apparently, they're using Fort Monmouth. For those who don't know, is an army base that got decommissioned for stupid political reasons that we won't go into. But like many army bases, military bases in the U.S., they have like a bowling alley and they have a bunch of dormitories and meeting halls and office buildings. I understand that Netflix is actually going to use the bowling alley intact. Did you hear that? It's crazy. For like
what? For
scenes.
filming? Oh, really?
They're gonna retrofit it. Yeah.
Oh, wow.
It's crazy. And
That's cool.
To be honest, it's a smart move by them. It's a ton of land. You have all kinds of buildings. You can hollow them out, and I mean, think about the barracks, right? You just hollow out the barracks, and you could have different sound stages. Every a couple per floor at least. Damn it!
Long history of tech in New Jersey.
Long history.
Are you still a proud like New Jerseyan, or are you like no, I'm a Florida man now?
I'm half and half. I do miss a lot from New Jersey. Like I miss, like you said, the history, right? Bell Labs.
Yeah.
If you like C or frankly most computing, you
Yep.
like Bell Labs.
Unix, right?
Unix, right? Edison, New Jersey has a whole thing going on, right? Thomas,
Mhm.
Menlo Park. Fort Monmouth was for those who don't know, was actually communications and signals intelligence base for a very long time. So they did lots of crazy shit there. Later on, it was just like a base that they had. What's the other one? There's another Camp Kilmer, right? They did a lot of
Oh, that's gone now, though. That's
That's
part
gone,
of
yeah.
Rutgers campus.
Yep.
But yeah.
Well, even Rutgers itself, though, right, has a great research and
Oh, yeah.
still does. Actually, my brother, I have a kid brother who's 20 years younger than me. He's applying to Rutgers, so it's
My wife just finished her PhD there, actually.
nice.
Yeah.
It's see, we should just do a New Jersey episode. Where
We
all
should.
do
We really should. Just talk about Jersey.
pork roll, egg, and cheese, right? Let's go. Go hook me up. Just don't tell my heart doctor; she'll be very pissed off. Well, the other thing I really miss, actually, to be honest, is public transportation. Just being able to hop. As much as I bitch and moan about NJ Transit, it was like, for instance, I'll give just a quick example, a quick aside. My wife and I went to see a play called & Juliet. It's I think it might still be on Broadway, but they're doing a touring company, and they came to Tampa, so we were there for opening night because we often go to the place opening night down here. And I hate having to drive. Like, the hardest part of the whole night is finding a goddamn parking spot.
Gotcha.
Why Tampa is surprisingly like a busy city with art and business and finance and tech. Why they haven't figured out that they should build a rail system? They keep saying they're going to, but they never do. It's just beyond me. Like, they would get so much more money from people with disposable income that say, "Oh, we could go to dinner tonight in the city," but God, then we got to park and you got to walk far, and I miss all of it. I miss NJ Transit to Penn. Hop the subway.
Classic.
Hopefully you don't get murdered. It's fine. This is the other thing from this living in the South for a while. New York, as cities go, at least in the U.S., as far as the ones I've been to, is not scary at all.
No.
Like, Tampa can get a little rough. We have a lot of shootings, particularly at night, weekends. I personally find Atlanta terrifying.
I've never been.
I don't know. I just had a rough. But the worst one is I was actually in Baltimore during the riots a couple of years back. That was rough. So yeah, it's the people who complain about, I'd be too scared to go to New York. New York is one of the safest cities, if not the safest city in the country. So
yeah. I would generally agree. I think like, I can go out in New York City and I never feel like, I mean, maybe I'm biased. I'm like a man, right? So
right. I mean,
but like, no, but like, I would even say, like, my wife, like, she feels like generally safe in the city. Like, she has no issues, I would say, like, going in there like on her own or anything like that. Like,
I mean, the worst thing is, like, maybe you'll have a drunk guy will be mouthing off on the subway or something, right? But
you get you get the odd characters, right?
But nothing harmful.
And you get like the stories of people like pushing people in front of subways that have happened. Like, it does happen.
It's super rare, though.
It's very rare. Yeah.
Especially now, because all those stations are so CCTV'd up. I mean, very hard to get away with anything. To see that, we'll have to do a follow-up episode on we'll just take a tour of NJ Transit lines. We'll
I was
start
gonna say, this could be like, we started at Vector Search, like, here we are now talking about.
Well, we have two different vectors.
New York City
right?
as a safe city.
No, we have two different vectors. You have the Northeast Corridor line from Edison, and I have the NJ Shore line from Little Silver.
Look at that.
Perfect. So you came here for coding. What you got was a New Jersey, New York Port Authority education episode. All right, Brian, it's been great. We're going to put all the links to Qdrant and to Brian's LinkedIn in the show notes. Reach out to him. As always, join the Coder Radio Discord. And do check out that USA Today article of me that I definitely plugged in the intro to this that I didn't record yet. All right, talk to you later. Bye, guys.
Thanks,
Bye,
Mike.
Brian.
Take care.